Hello everyone. A warm welcome to the next session of Deep Learning with Keras. So before going to proceed with this session, I hope you understand the previous session in which I have explained you the life cycle for neural network model in Keras. So tell me, what are the steps in life cycle of yeah neural network model in Keras? Tell me. Yeah, the first one is define the network. Second one is compile the network. Third one is fit the network or train the network, you can say. Fourth one is evaluate the network. And finally, the fifth one is, make the use of model prediction or use or do model prediction. Okay, got the point. Make prediction, you can say that. The fifth step. Yeah. So we are going to use all this concept in this session because now it's time for us to build our first neural network with keras with the real-time example. Okay. So as I told you that I'm going to build a first neural network with keras. I'm going to explain you, and we are going to use this neural network to solve a real world problem. Okay, so are you excited for that? Yeah. So see here, developing and evaluating the deep learning model. So in this session, first of all, I'm going to start with loading the data. So what the data set I'm going to use, I will show you that also. And then I will follow the life cycle of neural network model. So I need to define the model, keras model, and then I need to compile the model. I need to train the model or fit the model. And then I need to evaluate the keras model. And finally, I can make this model, I can make a use of this model for prediction. Okay, so see here, let's start. Are you excited to build our first neural network model? Okay, that's going to help us to solve a real-time problem, a real-world problem. So see here, in this session, you will discover how to create your first deep learning neural network model in Python using keras. So we will construct a multi-layer perceptron neural network or deep learning model with keras to predict whether a person has diabetes or not based on the information about the patient, such as the blood pressure, body mass index, age, insulin, etc. So this is our problem. What we need to do here? We need to construct, we will construct a multi-layer perceptron neural network model with keras to predict whether a person has the diabetes or not based on the information about the patient, such as the blood pressure of the patient, body mass index of the patient, the age of the patient, the insulin, etc. Okay. So the data was collected and made available by the National Institute of Diabetes and Digestive and Kidney Diseases as a part of PIMA Indians Diabetes Database. This example will use the PIMA Indian onset of diabetes binary classification problem. Why we are saying it's a binary classification problem? Because we need to predict our output is in terms of two values only. Whether a person has the diabetes or not. Yes or no, you can say that. Yeah. So what we are going to try, what we are going to solve here, we are going to build a multi-layer perceptron neural network model, or you can say a deep learning model with keras to predict whether a person has the diabetes or not based on the information about the person. Okay, what information we are going to use about the patient, about the person, such as the blood pressure of the person, the body mass index, the age, the insulin, okay, and some more information. Using this information, we can build, using this information, we can construct a multi-layer perceptron, a deep learning model with keras to predict whether a person has the diabetes or not. So are you excited? Yeah, so let's start with this one. So first one is load the data. So see, we are going to use the PIMA Indian onset of diabetes dataset. Okay, this is a standard machine learning dataset from the UCI machine learning repository. It describes patient medical record data for Paima Indians and whether they had an onset of diabetes within 5 years. Okay, so we are going to use the Paima Indians onset of diabetes dataset, and this is the standard machine learning dataset from the UCI machine learning repository. It describes patient medical record data for Paima Indians and whether they had an onset of diabetes within 5 years. As such, it is a binary classification problem. Onset of diabetes as 1 or not as 0. So it's a binary classification problem in which we need to predict whether a person will have the diabetes or not. Okay. All of the input variable that describe each patient are numerical. Okay. So whatever the data we are going to use here, okay, it's a numerical. It's all the data are in terms of numerical values. Okay. So this makes it easy to use directly with the neural networks that expect numerical input and output values, and ideal for our first neural network in keras. Okay, so now let me show you the data set. What data set I'm going to use? The Paima Indians. Yeah, this one, onset of diabetes data set. So let me show you how the data set look like. So see here. So you might think, what is this CSV file? So don't worry, I will share you this CSV file. Okay. So see, yeah, let me zoom it. So see, it has 1, 2, 3, 4, 5, 6, 7, 8, 9. It has total 9 columns. Okay. So the first column, it's about the information of pregnancies. Second, glucose, blood pressure, skin thickness, insulin, BMI, diabetes pedigree function, and the age. And this is our the last column, outcome. Outcome in terms of 1 0. This means yes, the patient has the diabetes. 0 means patient doesn't has the diabetes, will not have the diabetes. So see here, it has how many columns? Yeah, 1, 2, 3, 4, 5, 6, 7, 8, and the last column 9. Okay, and how many records we have? Tell me. So see, we have 768 records, 768 rows, because the, yeah, it's considering this column name as a first. So 768 rows we have. Okay. Now using this data set of diabetes, Paima Indians, yeah, okay, which is shared, which is available, which is given by the Paima Indians onset of diabetes data set. By using this data set, we are going to predict whether a person will have the diabetes or not. So see here. So let's suppose this is our first person. Okay, so the number of pregnancy for her is 6, and then the glucose is 148, blood pressure is 72, skin thickness 25, insulin 0, BMI, body mass index 33.6, diabetes pedigree function is 0.627, and age is 50. So for this lady, yes, outcome is 1. This means she is going to have diabetes. Okay, but the next one, the pregnancy is 1. Okay, glucose 85, blood pressure 66, skin thickness 29, insulin 0, body mass index of 26.6, diabetes pedigree function 0.35, and the age 31. For this lady, outcome is 0. This means she will not have a diabetes. Okay, so in short, our problem is to predict whether a person or patient has the diabetes or not using the information about the person. So what the information we are using? We are going to use the information about their pregnancies, what is the glucose, yeah, what is the blood pressure of the patient, what is the skin thickness of the patient, what is the insulin, BMI, diabetes, and the age of the patient or the person. So based on this information, we are going to predict whether a person will have the diabetes or not. So this is our data set. Okay, that is the data set that we are going to use it. Paima Indians diabetes data set. Okay. So I have shown you the data set. Now, before loading the data set, let's import the necessary libraries or packages. So import first of all keras. Okay. Next one is from keras.models, import sequential. Okay. And then from keras.layers, import dense, and then import the numpy, import pandas SPD. Okay. Now let's see the next thing. Now, once you import the necessary libraries, the packages, it's time for us to load the required Paima Indians diabetes dataset using the pandas read CSV function. So by the way, I hope you know the pandas, yeah, the very important library, yeah. So what is pandas? How you can read a file? How can you read a data from the CSV file? How can you read a data from the Excel file with the help of pandas? Yeah. So using pd.read underscore CSV. Yeah. So read underscore CSV. With the help of this one, you can read a data from your CSV file. So I will write PD. That is my pandas. So I have imported the pandas as PD. Can you see this one? Import pandas as PD. So I can write pd.read underscore CSV, and then inside a parenthesis, inside a single quote, I need to supply the directory where this file is present. So this file is present under the local disk F under the folder Alison or Studio and under this folder I have this file diabetes.csv. So pandas.read underscore CSV is going to read all the data from this file and it is going to assign to the data frame object data set. And then if you want to look at the initial 5 observation, initial 5 records of your data set of your, okay, then you can write dataset dot head. So let's execute the code. Okay, so I will open the Jupyter notebook. Okay, by the way, I hope you know that how can you open the Jupyter notebook. So see, the first thing is I'm importing the necessary libraries or the packages. So let me execute this code. So see, it's executing. Next thing is load and prepare the data set. Okay, so in order to read a data from the CSV file, I'm making a use of pandas.read underscore CSV. So pd.read underscore CSV, inside a single quote, I need to supply where this CSV file is located in my PC. So this file is located under this one. So see here. So I will copy it. Yeah. F, yeah, colon and then backward slash and the name of the folder. And then after that, again backward slash, write the name of the CSV file. Okay. The result of this one you're assigning to the data set. And then if you want to look at this data set, the initial 5 observation of the data set, then you can make a use of head function. So dataset dot head. So see, it's executing. After that, let me execute this one. So it's also executing. Okay. Till the time it get executed, let's continue with the next part. Okay. So see, there are 8 input variables and 1 output variable. Okay. The last column. Let me show you this one. So how many columns we have? First of all, count it. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is our outcome column. This is the, yeah, this is our target variable, or you can say the dependent variable. Okay, because it's depend on the information of these columns. So based on the number of pregnancies, glucose, blood pressure, skin thickness, insulin, BMI, diabetes, age, using this one, we are going to predict the outcome value, whether it's yes or no, 1 or 0. Okay, so you can see here, there are 8 input variables and 1 output variable. So what are those input variables? So my input variables are here: pregnancies, glucose, blood pressure, skin thickness, insulin, BMI, diabetes, age. And the output variable is the last column, outcome. Okay. Now we will be learning a model to map rows of the input x to an output variable y, which we often summarize as y is equal to f of x. Okay. So see, it's run. So let me run it again in front of you. So it become 3 and it will become, let me run it, it will become 4. So can you see this one? Dataset dot head. So it is going to contain all the information, all the data, A to Z data, including the name of the columns, whatever the data we have in our columns. So see, pregnancies, glucose, blood pressure, skin thickness, insulin, BMI, diabetes pedigree function, age and outcome. So see here, it's going to have all the data which is there in a file diabetes.csv. So this data set, that is a data frame object, it's going to hold all the data of this CSV file. So see here, 6, 148, 72, 35, it will be same to same. 6, 148, 72, 35, and then 0, 33.6, 0.627, 51. So see here, 0, 33.6, 0.627, 50, and then 1. So, and then because we are using dataset head, it is going to show us the initial 5 rows. So 1, 2, 3, 4, 5. Okay. Now, yeah, so what we are saying that there are 8 input variables and 1 output variable, or in short, you can say that generally there are two variables, you can say independent variable and dependent variable. So what is my dependent variable here? Outcome. Okay, and this is my dependent variable, and what is my input, what is my independent variable? For a independent variable, I need to access all the data of these columns: pregnancies, glucose, blood pressure, skin thickness, insulin, BMI, diabetes, age. So I will access all these columns and put it under the independent variable x, and this is my dependent variable y. Okay, in short, you can say. So these columns, I will make a use of all these column as an independent variable, and this is my dependent variable outcome. Okay, so what we are seeing here, there are 8 input variable and 1 output variable. Okay, so what are those 8 input variable? This one: pregnancies, glucose, blood pressure, skin thickness, insulin, BMI, diabetes, and age. So there are 8 input variables and what 1 output variable outcome. Okay, so we will be learning a model to map rows of input variable to an output variable y, which we often summarize as y is equal to f of x. Now see here, next thing, it's very important. The variables can be summarized as follows. So the first variable, okay, the first column is number of times pregnant. Okay, you might think, what is this? What is the meaning of this column? Pregnancies. So the first column, it says the number of times pregnant. The second column, the name of this second column is glucose. So the plasma glucose concentration at 2 hours in an oral glucose. The third column is tolerance test. Okay, this one. Okay. No, sorry. What is this third column? Yeah, blood pressure. Okay. So see, for your understanding, I will put it as like this one. Yeah. Now the first column is number of times pregnant. Second column is glucose. Third column is blood pressure. Can you see this one? Third column is blood pressure. So this indicate, yeah, diastolic blood pressure. And then what is the fourth column? Here the fourth column is skin thickness. What does it represent? It represent, yeah, triceps skin fold thickness. Okay, what is the next column? Insulin. So it represent 2 hours serum insulin. Okay. After that, what is the next column? BMI. What does it represent? It represent the body mass index. And then after that, we have the next column, diabetes pedigree function. So it's a diabetes pedigree function. After that, the next column we have the age, and our output variable is outcome 0, 1. Okay. So you understand the meaning of each of these columns of our data set? Yeah. Now let's see. Once the CSV file is loaded into memory, we can split the columns of data into input and output variable. Okay, so there are 8 input variables and 1 output variable. Okay, so here we need to divide given columns into 2 types of variable: dependent variable and independent variable. Okay, so dependent variable, that is our target variable. Independent variable is our feature variable. So the data will be stored in a 2-dimensional array where the first dimension is rows and the second dimension is the columns. So that is rows comma column. Okay, so once the CSV file is loaded, so we have read a data from the CSV file with the help of pandas.read_CSV, and the result of that we have assigned to the data set, and then dataset.head, with the help of this code we have seen the initial file records of our data set. So once the CSV file is loaded into the memory, we can split the columns of the data into input and output variable. So here you need to divide the given columns into 2 types of variable: dependent variable and independent variable. The data will be stored in a 2-dimensional array where the first dimension is rows and second dimension is the columns. Okay. So like this one, x is equal to dataset.ilog Okay, so you might think, what is this? ilog. So see, the ilog indexer for pandas data frame is used for integer location based indexing or selection by the position. So what is my data set name? So I have the data set that's going to contain all the data of our CSV file, diabetes. Okay, so data set dot ilog. Okay, so the first colon after comma. So actually, you don't writing anything here before this colon. You are not specifying any number before this colon, and even you are not specifying a number after this colon. You are specifying directly comma and then 0 comma 0 colon 8. So this first one is related with the rows. So this means you want to access all the rows of 0 to 7th column. 0 to 7th column. 8th column will not be included. So the data set dot ilog all the rows, okay, all the rows of the columns from 0 column till 7th column. The result of this one you are assigning to the X. Now you might think, okay, so if you want to give the number for this one, okay, so by default it's in case of this one data frame, okay, so this is our 0 column, 0, 1, 2, 3, 4, 5, 6, 7. So I want to access these 7 columns. I want to put it under independent variable X. So I will write X is equal to name of the dataset dot ilog, and then all the rows comma 0 colon 8. This means all the column from 0 till 7th column. So 7th column, what is the 7th column? This is 0, 1, 2, 3, 4, 5, 6, 7. Okay, so X is going to contain all the rows of these columns. Okay, and then Y is equal to dataset dot ilog. Okay, all the rows comma 8. 8 means, what is this 8? The column number. So 8 column number. Yeah. So is it 0 colon 8? So 0 colon 8 means 0 to 7. But if you just write 8, so it is going to access the 8th column. So the column number start from 0. So this is 0, 1, 2, 3, 4, 5, 6, 7, 8. So this last column outcome, this is my dependent variable, and I'm assigning it to the variable y. Okay. Now we have divided, okay, the given columns into two types of variable, dependent and independent variable. So see, under the independent variable, it is going to have all the records, all the rows from 0 till 7th column. And y is my dependent variable, that is going to contain the last column, that is 8th column, all the records, all the rows with of 8th column. Okay, now next thing is, what are you doing here? You're just writing dot values, dot values. What is the meaning of this one? So see, values attribute return a numpy representation of the given data frame. It's going to represent, it is going to return numpy representation of the given data frame. So let's see, let's run this code. So see, yeah, data set dot head, you can see this one. After that, what we are doing? Yeah, we are dividing the columns of our data set into independent variable and dependent variable. So X, it's going to contain all the rows from 0 column till 7th column, all the rows from 0 to 7. So the result of this one I'm assigning to the X, and data set dot ilog all the rows of 8 column. Okay, so in, yeah, so it is going to have, what is the column name? 8 outcome. 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so let me execute this code. So see, it's executed, it's 5. Okay, after that, if you want to look at the X, so just write X here. Let me run the code. So see here. So X is going to contain, as per all, I am as this code. What I explain you about this code, it is going to have, it is going to contain all the records, all the rows of the columns from 0 till 7. So see, pregnancies, glucose, blood pressure, skin thickness, insulin, BMI, diabetes, pedigree function, and age. Okay, 0 to 7. This is 0, 1, 2, 3, 4, 5, 6, and then last one age, 7. Okay. And then if you want to see why, So let me run the while. So see here, it's a last column outcome. Okay, 0, 1, 2, 3, 4, and then last 776. Okay, got the point. Okay, just okay, yeah. Next, let's see the next thing. Okay, if you want to write here x, you can see this x contain 768 rows with 8 columns. Yes. Okay, got it. Now it's look like, yeah, it's a data frame. Obviously, yeah, because data set is my data frame object. So x is going to contain all the records of our data frame from the first column pregnancies till age. Yeah, and y is going to contain all the records of the last column outcome. Yes. Okay, so now let's change it to an array numpy array representation. How can you change it? It's very easy. Just write x is equal to dataset dot ilog. Okay, dot values. Y is equal to dataset dot ilog. What is the meaning of this one? All the rows of 8 column. All the rows from 0 to 7th column. Dot values. Okay, dot values. It is going to change the pandas data frame to a numpy array representation. Okay, so now let me run this code. So it's run. So see, initially x look like this one. Now let's see how the x look like. Now can you see this one? How the x look like? So we have changed pandas data frame to a numpy array representation because it's this values attribute return numpy representation of a given data frame. So numpy array representation of this data frame x. So how it look like this one? So initially, see here, this x, it contain the column name also, pregnancies, glucose, blood pressure, skin thickness, but we want to make a use of all this data 6, 148, 72 because it's a numeric data. So what I have done, I have converted this data frame into the numpy array representation with the help of this code dot value. So changing the pandas data frame to a numpy array representation. Now how this x look like? It contain all this data. Yes. Even if you want to see how the y look like, you can see this one. Yes, how the y look like. Yes. Okay, got it. Now let's see the next thing. So now we are ready to define our neural network model. So we're done with the first thing, loading the data. Okay. So now loading the data, what we have done? We have made a use of the CSV file diabetes.csv, which is provided by Pima Indians Diabetes Database. Okay. So before going to load the data, we have imported the necessary libraries and packages. And then in order to read a data from this CSV file, we have make a use of pandas.read underscore CSV function. So see here, pd.read underscore CSV, and then inside a parenthesis inside a single quote, we supply the path to this file. And the result of this one you can assign to a data set or data frame object, whatever it is, data set. Okay, and then data set dot it. So you can see this data set is going to hold all the records, whatever the values are there, whatever the things A to Z, whatever we are writing, it is there in this diabetes.csv. Whatever the records, whatever the data is there in this CSV file. Okay, now this data set is going to hold all those records, all these things. So in short, pd.read underscore CSV, the result of this one you are assigning to data set. So it is going to hold all the data of this one, diabetes.csv. So data set dot head. Okay. So data set dot head means it is going to show you initial 5 rows of your data set. So as I told you, this data set is going to contain all the records of with all the rows, all the columns of the file diabetes.csv. So dataset dot head, it is going to show you initial 5 rows. Okay, with the column name, pregnancies, glucose. Okay, after that, what we have done, the next thing is we need to divide our given columns of our data set into independent variable and dependent variable. So we consider this columns. We get pregnancies, glucose, blood pressure, yeah, and then skin thickness, insulin, BMI, diabetes, pedigree function, and age. So we consider these columns under the independent variable, and we consider the last column outcome as a dependent variable. Okay. So for that, what we have done, x is equal to dataset that I log all the rows from 0 column till 7th column, and y is equal to dataset dot I log all the rows of 8th column. So x is going to contain all the records from pregnancies column till age column. So you can see here pregnancy till age. Whereas y is going to contain only the last column output. Yeah, what is the last column? Oh, sorry, outcome. So now, since we just want to deal with the numeric values, so what is the best thing? Let's change the pandas data frame to the array representation. So just write dataset.ilog, okay, like this one, and then dot value. So it is going to change the pandas data frame to the array representation. And then we have seen how the x look like, how the y look like. Yeah. So yeah, can you see this one? So at this point, now we are ready to define our neural network model. Okay. So what I will do, I will continue with the next point of defining our neural network model in the next session. I will continue with this next session with the next point of defining the keras model. But as of now, I hope you understand how you can load a data. Yeah, so for loading the data, we have make a use of pd.read underscore csv file so that we can read all the data from this diabetes.csv file. And then we have divided the data, we have divided the columns of our data set into two types of variable, independent variable and dependent variable. And the data will be stored in a 2D arrays where the first dimension is rows and the second dimension is column. Okay. And then, yeah, we have performed this code, and then we have executed this code so that our pandas data frame get, okay, converted to the to a numpy representation. Okay. Values attribute return a numpy representation of given data frame. So it's a numpy representation of this data frame x and y. So changing pandas data frame to a numpy array representation. Okay. So at this point, we are ready to define our network. So I will continue with the next point of defining the network, defining the keras model. Okay, in the next session. Okay. Yeah.